What up, physics dudes? Let's get this party started. We're going to be doing a riddle, and we're going to figure out how to do this. And I'll be honest with you, I don't know how to do the whole thing off the top of my head. So today is going to be us floundering around and trying to figure it out. And my challenge here is I have an 8th grader here, and I'm going to explain it to everyone, including the 8th grader. So ask me questions, because I think this will blow your mind. Sound good? Yeah. And the reason why I want to do this is because I was actually inspired by you.
I'm going to get that promo.
The reason being is because, Emma, the reason why I was inspired by you is because we were doing a really big equation the other day on the board, right? This was a while ago, right?
You're talking about the Canon one?
Right. We were doing a really big equation, and you hung in there. And I'm going to show you again something that is really crazy and really difficult, but I don't think the concepts are too hard for you to understand. I will have to teach you new things that you haven't seen before. It has to do with forces. It's not really that bad. Really, it isn't. Okay? I think that I will try to do this in the best way possible, and I'm explaining this to 2 physics students and 3 non-physics students. So I'm going to try to explain this the best I can using pure math and everything. All right, so here's the question that I have. And this actually goes out to Maston and Brandon, because you haven't seen this before. Well, it's because I explained this to them. Or at least I explained this to them not with math, but just like a bunch of what we call arm waving.
Oh,
all right? Yeah, that's the thing. All right, so check this out.
Thank you.
You're in a boat in the middle of a lake. Okay? Imagine in your head, can you envision a giant lake in the middle of a boat and all that kind of stuff? You take a penny out of your pocket. You throw it into the water. What happens to the penny? It sinks. Why does it happen? Why does that happen? Do you guys know?
It's heavy. It's denser than water.
Because the density of the penny is denser than water, right? Right. It's not necessarily heavier. You have to, when we talk about these things, you're going to have to talk about density, per se. So metal is denser than water. Pretty undisputed. Got it? As a result of that action, did the water level rise, fall, or stay the same?
Oh, I still remember it.
Well, I still do. It's a penny, so I don't feel like it'll do much to a lake.
You're right.
In the sense
You're right.
of if you just like stick something in.
No, I totally agree. If it does anything, it's not going to do much. Nothing that I can actually use a ruler to measure. Even if I had like a laser ruler. A laser ruler. It's a penny in the lake. Right. All right, so let me ask you this. Let me prime the field here with asking you. If I go down to the ocean right over there, and I take a drop of water, and I drop that water into the ocean, did the water level rise?
Such an insignificant amount.
It is an insignificant amount, but that's not my question. My question was, did it rise?
Yes. But
Yes.
By such, oh my God.
So in the same light, I'm asking you that question. The reason why I'm doing this is because Einstein did Gedanken experiments, which is basically he thought about it. Because there's nothing Einstein couldn't actually, to this day, we can't test out a lot of Einstein's theories because we don't have spaceships that go the speed of light.
Yeah. Not yet.
Or even 0.9 the speed of light.
Yeah.
I kind of made up.
We are
Sure.
working.
Sure.
Like you guys can't test this.
Right.
That you know of.
No, but it makes sense. It makes perfect sense logically, and so this is in the light of doing that. So, as a result of throwing a penny into the lake, will it rise? Will the water level rise, fall, or stay the same? Rise. All right, let's test that. So, one very important principle in that is you guys all argued with me to say that it's so insignificant. How are you going to measure it, right? Would it be all right if I made some of the parameters extreme so that way we could see the effect even more? And then when I change those parameters back to the original question, it will still do the same thing, just at a much smaller scale. And that's an important physics concept. That's not even important physics. That's an important science concept. Sound good? So I have my lake, small lake. I got my boat,
Giant boat.
If I'm comparing this boat to a lake, this is like the Titanic in the Alawai. Okay?
A waste,
And I
basically.
got my penny, which is basically the equivalent of having like, I don't know,
Giant steel mill.
yeah, a steel mill inside of my Titanic, inside of the Alawai. All right?
Yeah.
All right. So I've got my boat that floats.
Yeah, that raised that definitely.
All right, cool. Yes. So
I'm so
do me a
excited.
favor.
What?
Put the.
No, please, hold on.
Yeah, all right,
Yes,
fine.
Elijah, you did this already.
I want you to put the tape. Okay, what is going to happen then?
You
What am I
can
doing?
take the weight out of the boat.
Yes, I'm. Yes.
The water level's gonna
Put
go
this,
down
put
instead.
the
Is it
tape
going to go
on
down or up?
where the water level is right now.
Put the tape where the water level is.
Where should I put it?
Let's put it.
On the side of the
Let's
Put
put.
the top of the tape
Yeah,
at the
one
bottom
mind
of the
blowing,
water
dude.
camera.
Yeah.
level.
It's
Well, I want it so
see,
that.
you're probably
The top
thinking
of it?
it's
Yeah. so
not
that
going
we-
to change because the water level technically doesn't change.
no.
Guys, just stop giving
Put
away
that high
secrets.
All right.
Sorry, we've already wrapped
It's lit.
that up.
Yeah, yeah.
So your thoughts are is it's going to go down or up,
If you take,
or it's not going
Can I
you're
to,
keeping the same amount of.
or is the effects going to cancel out and keeping it the same? That's
Yeah.
all right.
You're
So
going to want to eyeball this.
so we're going to take the pennies out. Obviously, if we take the pennies out of the system,
Water's going to drop.
the water level is going to drop, right? Of course, right? Like it's significantly lower, right? But as I add the pennies back, is it going to raise it up to that original mark? That's, I guess, my question. What is that?
We're dumping them in water, right?
We're basically throwing an expensive steel mill into the Alawai.
All right.
Homie, I was here for the.
Okay, there we go.
Whoa, why did it raise different?
All right, so here, go for it. Put it down.
Okay.
Pull her down.
Ah, it's different.
So what I'm going to do with you guys today is I'm going to go over science principles. I'm going to go over physics, and I'm going to go over calculus with you, all taught to the 8th grade level. Sound good?
Raj.
All right. Well, what happened, by the way?
It dropped.
It dropped.
It dropped.
And then when you put it back in, it's gonna raise as much.
Right, right. So what the heck is going on?
Weird science.
So I'm going to prove to you what's going on. Okay, let's talk about it and give you the hand wavy explanation first. And then I'm actually going to give you like the meat of it. The hand wavy version is this. The boat, because the boat is not as heavy, it comes out of the water. Obviously, when you put stuff into the water, the water level will drop as the boat rises out of the water, right?
Right.
But there's also the effect of the water level will rise when you throw crap into it, right? So, which effect has more of an effect? The
Oh.
water level dropping because the boat is rising out of the water, or the crap you're putting into it?
The first one.
And I would say this. Obviously, it's obvious. It's the boat rising out of the water has more of an effect as putting all that junk inside of the water. You can see that literally right here. But I would say this. It all has to do with this one very simple thing that we can all agree upon. It's all going to be based on this idea that the density of the metal is greater than the density of water, and therefore it sinks. That's all you need. Okay? And do you know about density a little? All right. You learned that what, like in 2nd grade?
You learn
Yeah,
that
when
when
I was
it's
in
science. What is
Learn that if you
one?
hit your pen.
grade? No.
Learn that if you punch a rock, it's too dense and doesn't work.
All right.
You're
So
not Kikaya.
I'm gonna go over. I'm gonna go through this equation, and I'm going to try to teach you the science as I go through it, and it's gonna be intense. I'm just warning you now.
Chicken.
Like, take off my jacket. It's intense.
Whoa.
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 Alright.
Flip equations.
All right. So
UH.
yeah, my wife was commenting how fat I've been getting, and this is woman becoming like a leotard.
She was.
Um,
No strong visuals.
Yeah.
Woo.
Oh my god.
let's start class off with that. All right, so check this out. Let me just set up the problem. I'm going to draw the picture. That's the first principle you need in physics. Draw a good picture.
Crap. I'm not gonna be good at this.
Well
No.
then.
You don't need to draw a pretty picture. You just need to draw a descriptive picture.
Didn't you just draw a picture?
I did, but I was just drawing it to think about.
Well, I failed.
it. Okay.
Oh my God, Elijah.
I know can draw.
I can see that.
There's my picture. Can you guys see it?
Hi.
Here's the tank. The big thing is the tank. Here's the water level. And then this thing right here is the boat. And I guess I'll put a squiggly dot there for that's my penny. Cool? And then picture number 2 is this is before. This is after. It's pretty simple, right? Let's put after. Okay. So let's draw in some labels and tell me if you're confused with these labels. I think something that's important in this problem is the area. I'm going to call it A little t. That's the area of the lake, the bottom floor area of the lake. Okay? And I'm also going to have a label over here, the H of t. That's we'll call it H of t1. So that's the height of the tank in the first picture. Okay? That's the height of the water in the first picture.
I was gonna say, if we're doing the tank, it doesn't really matter.
Oh yeah. The
Just
tank
seconds.
doesn't necessarily matter, but
It's the water.
yeah. But okay, fine. We can call it HW1
Oh, okay.
if that makes you feel better.
No, I was just saying. That's what I already looked at.
All right.
Sorry.
Let's see. In picture number 2, or let's keep on with picture number 2. I think that the area AB is going to be important. What is that?
Boat.
Area of the boat, the bottom of the boat. Got it? And it doesn't really matter the shape, but I think maybe we can consider these perfect cylinders. Okay? So, over here, this is going to be HB1. And that stands for how far below the surface the boat is penetrating the water. You know how they, on ships, they have that little line over there? And then, depending on how heavy it is, the water will go up to that line. And if it goes up to that line, you're in big trouble.
Really? That's trouble.
Yeah, well, that's why it's red.
Oh, okay. I was like,
I didn't know it was red.
Well, no, that just signifies like this is like your maximum point. You don't even want to get close to this line, or else you're gonna.
At this
Yeah.
point, you're sinking.
At this
You're
point,
gonna
you're
Titanic.
anything more, you'll probably be in a very bad state. Got it? All right. So, depending on how heavy that penny is, this HB is going to change. That makes sense, right? And I think another variable that I'm going to have is the weight of penny. So I'm going to call it WP. Cool? And is that it? Is that all I need?
I assume.
I'm gonna label this one right here. It looks like a funny looking P.
I like it. What is it?
It's called rho.
No.
It's a Greek letter, or R, I guess. I don't know. And what rho sub W means is the density
Yep, we did use this.
of water. How do I know it's the density of water? Because I have that little W by it. Cool. So if I have a rho with a little P by it, and these are two different letters. This is an American P and a Greek rho. This is the density of what? What do you think?
You are currently the only person in this conference.
The density of the penny. Yeah, very good.
I was so unsure of myself.
All right.
I was like,
So nothing new. No crazy math. In fact, all I've done is draw a picture and put letters by it, and explain what each letter means. Are you lost yet? Not really. Right? Okay. I think one of the equations I will need eventually, so I want you to write these down on your paper, is this. Density is equal to mass over volume. Cool.
Oh my.
That's not new, right? That you learned that.
This is all for physical science.
Right. So
Remember this.
you learned that when you were like 2 years old, right?
No.
Yeah, absolutely.
Uh,
It's like freshman year.
Yeah.
Freshman.
Okay.
Those letters,
But it's
yeah.
not. But it's not crazy.
It's not, yeah.
Is it right? Density is mass over volume. Okay, write that equation down because I'm totally going to use that.
Got it.
I have it in my physical science notebooks.
Okay. I'll probably use this form of the equation actually.
Using that one too.
Mass is equal to the density times volume. All I did was I multiplied both sides by v. That doesn't freak anybody out, right?
Turning into a pervert again.
Another equation that I'm going to use and pull out of the side of my head is going to be W is equal to mg. And this has to do with our forces. This has to do with our chapter on forces. The weight of an object is equal to mass times gravity. Are we cool with that? So, would it freak you out if I wrote this? W equals rho vg.
No.
Because we just discussed
Yeah.
that m was rho v, and this is density times volume, and then if weight is equal to mg, then weight is equal to rho vg.
Would you then put the row V in parentheses?
I could. It doesn't matter. Because I'm
Just to
multiplying
make sure we
everything.
don't get freaked out.
Yeah, all right, fine. I could do that just so to calm you down. All right.
I'm sorry.
So nothing freaky yet.
Negativity.
Okay.
It's
All right.
not like review kind of.
It's not review yeah, I guess it could be review, but I'm going to try my best to explain this whole problem. That's going to look crazy, and if you like derive this in Starbucks, you're going to be full on like beast mode. Everyone's going to be looking over your shoulder. You're like, dang, you're smart. But it's
I only
really
know
just
one
based off of
equation.
this: density is mass times volume, or mass over volume, and then weight is equal to mass times gravity. There's one other thing that I think I need to teach you. It's talking about the buoyancy force, which is what Ms. Sononini covered a lot in her physical sciences with gas laws and all that kind of stuff. In fact,
Not even gas laws, just density.
it probably has a lot to do with Bergman.
Yeah.
Actually, no, it has nothing to do with Bergman. This buoyancy force thing. It does have something to do with Bergman, but never mind. Anyway, all right, moving on.
Nerd.
So nothing freaky there. Got it? Okay.
It's chemistry.
So I'm going to try to do this. I'm going to say that
With density, yeah.
the volume or the area of the tank times the height water 1 is equal to all of this, right? So it's equal to the volume of water. I should put a VW here. This stands for the volume of the water that's in the tank, right? Plus the area of the boat times HB1. Anything freaking anybody out?
No.
Right? Okay. And I'll be honest with you, I wish that if I were to, you guys asked me this kind of on the fly, or we decided to do this on the fly, so I wish I had like my notes and I could just refer to what the next step is. But today is basically going to be me playing around with math. And you guys actually opted to come in. They have to be here. You guys actually wanted to be here. Great.
So you guys are weird.
All right.
My
So
ride only comes with 3.
Oh.
there's an interesting. Let's try to figure out what HB1 is. Let's try to get more of this story here. Okay? Let's figure out what HB1 is. And here's where I'm going to have to teach you some physics. HB1 is equal to, all right. When it comes to measuring density, was it this guy? It was, who's the guy? Archimedes. That's right. Archimedes came up with this thing where he was hanging out inside of a bathtub, and he was trying to figure out whether or not the king's crown was gold, was pure gold. Because, all right, so the story goes, the king had some crowns made, and the king didn't know whether or not the jeweler that he gave the crown or the gold to, the pure gold, was all going to be put into his crown, or if the jeweler was going to make a silver or copper thing and then just plate it with gold, and he has no idea. You know what I mean? And he could add some crap in there to like make it feel the right weight and everything, but it, like the king didn't know whether or not he was being cheated by his lead crown maker or whatever. So he asked Archimedes. Now Archimedes was sitting in a bathtub and watching the water go up and down, and he was really thinking about this because the king was a jerk, and so if he didn't figure this out, the king would cut off his head. So he was thinking and thinking and thinking about it, and then all of a sudden he came, and the story goes, he stood up and he shouted, "Eureka!" And so he runs down the street, buck naked. "Eureka! I figured it out!" All the way down, stands in front of the king, naked, and says, "I figured it out." And what he did was he said, it has to do with density. So he drops the crown inside of the thing, and he drops the same amount of gold inside of water, and then he says, "Oh, okay, well, this is not pure gold." And so then the king cuts off the jeweler's head.
Oh, okay.
But at least it wasn't his head.
Right, right.
All of his-
So anyway,
this
well-
just goes to prove that all great ideas start from that.
Well, here's what I'm
More or
saying.
less.
Quote. I've heard it before.
Here's what I'm saying.
Einstein said
The
it.
amount of buoyancy force that you feel, like if we're inside of a boat, and the amount of buoyancy force, so I need to have forces that balance out. So I've got an upward force that I'm going to call FB, and I got a downward force that I call the weight. Are we cool?
Yes.
Now the amount of buoyancy force that you feel is actually equal to the weight of the water displaced. Okay, you've heard that before.
Probably from
So what that's saying is, like, if I have some kind of container, okay, if I have some kind of boat, okay, and I want to figure out how much force this boat feels pushing up on it, then what I would do is I would take that boat out of the water, I would fill it up with water, and I would pour that water onto my scale and figure out exactly how much that water weighs. However much that water weighs, that's how much force is pushing up on that boat. Does that make sense? So this FB is equal to WW, the weight of the water. Sound good? Not confusing.
No.
Okay. WW is equal to the mass of the water times gravity. I just showed you that equation, so it shouldn't be something freaky to you. Mass of water times gravity is the density of water times the volume displaced times gravity. Are we cool? No, it's not permanent. It has nothing to do with permanent.
Turning into what it was.
Okay, all right. The volume is equal to the area of the boat times the height, V1 times gravity. No, yeah. This is the volume. It's the area times the height. Right?
Cube. His volume is cubic.
No, the area is measured in meters squared. The height is measured in meters, so
Okay. Yeah.
that all multiplied together is meters cubed or whatever. We cool?
Gotcha.
So nothing crazy. And this W right here, that's the weight of the boat. So the weight of the boat is actually, I should say, well, I guess it's equal to the weight of the, I'm going to put an E plus the weight of the pen. WE plus 1. So this is the weight of the empty boat plus the weight of the pen.
Oh, okay.
Cool. I forgot to define it like that, so I probably should have put that up there. So I'm going to have to make up some new variable called the WE. That's the empty boat. Cool? And this force should be equal to this force. So
You're floating.
let's see. WE plus WP is equal to density of water times the area of the boat HB1 times gravity. Cool? Did I lose you? No, nothing crazy. Would it be alright if I put the density of water over here and gravity over here? And I have area of both HB1? I just took these and divided them.
Yep.
Are you good with that? Hey, I can replace this thing right here with this.
Oh.
Right?
Oh yeah.
Okay.
You are currently the only person in this conference.
Sort of makes sense.
So I'm going to make this equal to volume of water plus the weight of the empty boat plus the weight of the penny over the density of water times gravity. That's replacing the AB plus HB1. Cool. Brandy's wondering, what the hell is this? Where's any of this going? Right?
What? No. It's
What?
Like
Or is it
half
interesting?
two, so I'm powering it down a little bit.
Don't read her mind.
Okay. I honestly think that's as much as I need. Did I lose anybody with this?
No.
Okay, all right. I'm going to apply the same kind of principles to this one. This one's a lot. Oh, it's the same. It's the same deal. The area of the tank times the HB2 or HW2, the height of the water in the second case, right, is equal to the volume of water plus ABHB2 plus volume of penny. This equation is a little bit different from this thing. Why?
Yeah, it's the penny.
Because I need to account for the extra volume of the penny. We good?
Yep.
Yeah.
Yep.
This HB2 is going to be a little bit different. Let's figure out what that is. Let's figure out what this thing is right here. Remember I told you that the weight of the water is equal to the density of water times the area of the boat times HB2 times gravity. That's the weight of the water that's inside. That's the buoyancy force. I could call it FB equals that. In that picture I had, FB was pushing up, right? But this time, the weight that's pushing down against it is not WE plus WP, it's just what? It's not the weight of the empty boat plus the weight of the penny, it's just the weight of what? It's just the weight of the empty boat, right? Because empty boat, pennies are in the water,
Oh.
right?
Right.
So what is the weight of the boat? Well, before it was the weight of the boat plus the weight of the pennies. Now it's just the weight of the boat.
Oh,
Does that make sense?
Yep.
So this is equal to WE. We cool?
Oh, yep.
Yeah, nothing creepy, nothing freaky. So can I write down that AB times HB2 is equal to WE over rho WG? Sorry, that's a WE. Is that all right with you? And I'm going to take this HB2 and I'm going to place it in here. I'm just warning you. So ATHW2 equals VW plus VW plus WE over rho WG plus VP. We cool with that?
I see where I think I see where.
All right, I'm going to erase this bottom part to give myself a room. Honestly, I'm doing my best. I know it looks crazy, and I know that there's lots of pieces coming together, and I've always wanted to actually break this problem down. So that's why that's my motivation for actually saying,
Doing
well,
this.
hey, you guys are willing to stick through my craziness? Let's do it. So I can actually record a video and have this thing forever. So then whenever I give this riddle to people, or you give it to people, you can show people and say, well, this is where it comes from. It makes perfect sense. Does it make perfect sense to you?
You know this insanity?
Yeah, it does,
There is a
but-
reason behind it.
No, but I mean, this is not that hard.
I'm
Yeah.
just like not feeling your arms anymore.
Huh?
I'm I'm just like not flailing your arms anymore. So I was kind of worried.
Oh,
So,
okay. All right.
Unless you flying his arms around.
All right. What do we do? Okay, let me play with this thing a little bit more.
Can we make them equal to each other and start canceling stuff out?
I kind of want to do that.
Yes.
But I know they're not equal. Because I know that
'Cause there's-
AT times HW1, I know that HW1 and HW2 aren't the same number. So I can't set them equal to each other.
Oh wait.
It's not. Because
What
the
I'm-
water
I'll-
rises and falls.
I'll show you what I'm going to
I'm
do.
trying to figure
And I think it'll be. I think it will make a lot of sense to you. But let me play with this a little bit more because I think that this would probably be helpful. This WE, can I just make that the mass of the boat times the density of the boat? Right? Because weight is equal to. No, wait. W equals mg. Mg equals rho v g. Okay, so I need this W is the density of the boat times the. Oh, yeah, okay. I'm going to change this WP. I'm going to do that. I'm going to mess with that thing. This WP is the density of the penny times the volume of the penny times gravity. Cool? So let me rewrite this one just a little bit. I have equals to volume of water plus the WE over rho WG plus the density of the penny times the volume of the penny times gravity divided by the density of water times gravity. Are we cool with that?
Yes.
Nothing freaky. I just, this is this plus this divided by that. I just separated those. And I rewrote WP as rho VG. By the way, this cancels. Cool? Gravity cancels with gravity. Yeah.
Got it.
All right. Here's what I'm going to do. Did you figure out what I should do?
Gotcha.
Should I cancel them equal to each other? That wouldn't make sense.
I know there's something in the back of my mind that's telling me that there's something you can do, but you just can't remember.
I'm going to take a ratio. A ratio is, I'm just going to take this crap,
The whole thing.
I'm going to divide it by that jump. Okay? Here, let me explain the ratio to you. Okay? If HW1, all right, if I take a ratio and I take some number and I divide it by some other number, if it's equal to 1, then what can I conclude?
That's equal. That.
That this number was the same exact as that number. Cool? If it's bigger than 1,
You are currently the only person in
yes,
this
you told
conference.
me that 3 times now. If it's bigger than 1, then what can I conclude?
They're not equal.
Oh, they're not equal. But the one on top must have been bigger than the one on the bottom.
Right.
Okay? And then if it's less than 1, if it's some number that's smaller than 1,
And the denominator is small.
then the denominator was the one that was bigger because a number divided by a bigger number is a number that's smaller than 1. Does that make sense?
Yeah.
Okay. So what I'm going to do is I'm going to take the ratio of this divided by that. And I'm going to say that if this divided by that equals 1, then the water level stays the same. If this divided by that is bigger than 1, then the water level rose. And if this divided by that is smaller than 1, then the water level dropped.
Okay, I feel like I know the answer. Did we cover something like this? I feel like we
No,
covered
no,
something
I don't
like
think
this
you've ever
last
done
time.
something like this
My
before. I don't
brain
know.
is
I feel like
starting
it
to throb.
asked for something
Okay.
like that.
But like, I know it looks crazy. But it's not really that bad.
I feel
It's
like
not,
we did something like
honestly,
this in
I
algebra.
understand
I'm going to divide by ATHW2 divide by VW plus WE over rho WG plus
You got
VP.
fractions.
I know, it looks horrible.
Yeah.
You can say that again.
It is the bazooka, I
Okay,
believe.
wait, so we've never covered anything like this in algebra because it looks so familiar.
No.
Like I feel like we did something
We've done ratios, and you've probably done ratios in math.
I think you just have PTSD. So like
But
PTSD from what?
I've done this before.
From
large
Right.
equations. Yeah. So right now your brain's just like, it looks just like it.
oh, I'm sorry, I forgot to write a very important fact that I think we all agreed upon.
Your penny.
Was the density of a penny is bigger than the density of water.
That is correct.
Yeah.
Right? We knew that, right? That was
You didn't need to write that.
that's not new information, right? Okay.
Wait, what?
Right. So check this out. The area of the tank cancels out with the area of the tank.
Yes.
I can't just go through and cancel these out. If they were all multiplied, then I could. Oh, the BW on top cancels with the BW on the bottom. This thing cancels with that on the bottom. Cool. But I can't because there's a plus sign in between. All right. Now we're getting into the calculus of things.
Oh, it's lit.
Yay.
What is it?
And oh, it's
Normal
lit.
math.
What is lit?
I don't know either.
Don't
Don't
worry about
I
it.
don't know
It's
really.
good.
Good, cool, awesome.
Really?
Like, oh,
Is that
it's
the-
lit. Yeah,
Is that the new? like-
exciting.
Don't look at me, man.
It's-
Miss Sonanini, have you used the word lit?
I don't think it's in my vocabulary, but I've heard it.
You've heard it?
It's
Oh.
the youngins. It's the youngins.
See, you're so much cooler than me. That's what makes you so much cooler than me. Okay, so this is where we're
I'm
getting
bored
into
of this
the
time
calculus.
and I don't know what that word means.
And the calculus of it, by the calculus I mean we're going to look at numbers and see how they behave. That's what you do in calculus. You look at numbers and you see the trends of how things go and all that kind of stuff. But here's what I want to point out to you. VW and VW on top, they don't, top and bottom, they don't cancel. WE over this thing, but they are the same, right?
Okay.
So this number plus this number is the same as these two things. So I can't necessarily cancel them out mathematically, but what I can say is if this number right here is bigger than this number right here, then this thing is whoa. I think I just proved the opposite of what I was supposed to prove.
Oh.
Oops.
Oh,
That
Lord,
plot
you did.
That's the water rose?
Yeah, yeah.
Restart.
No. This is good because it means I screwed up. And you guys are like, well,
Learning experience.
well, no. Remember, I told you, I didn't tell you,
Ball.
I didn't tell you that I knew how to do this thing right off the bat. I told you I was going to play with it until we figure out the right answer.
Maston is never allowed to man the cannon.
No, but I mean, this is exactly what the point I wanted to try to make
You
is.
fire the nuke.
Here's a
1
big
meter from
equation.
us.
This is crazy looking stuff. It should make sense, and right now it's not making sense to me. Let's look at it. Let's look at it very closely.
What did you
What
do?
I'm saying here is that
Wait. Can you cancel out the density of water with the density of water, like the density of the P
No,
with
blasphemy.
you can't cancel those.
take the density of water and cancel it with the density of water on the bottom side.
Oh, this part right here.
I don't
The
know. I'm
W,
thinking-
yeah.
I'm thinking
No.
out loud.
No. Here's what here's what I was gonna go at.
At least she's trying, Maston.
He just.
Okay, wait. If H. No. No. This makes perfect sense. I just made my explanation a little bit wrong.
Okay.
If this number on top is bigger than the number on bottom, right? Then when I divide them, that number is going to be bigger than 1, right?
Yeah.
So my explanation is when I said, hey, if this ratio is bigger than 1, then the water level rose, but that's not true. If this ratio is bigger than 1, that means the top one was bigger than the bottom one, so the water level fell. Does that make sense?
No.
Okay.
This represents the height of something, the height of the water on top, right? Or not on top, but to begin with. This represents the height of the water in the end. Okay.
Right.
Let's do the scenario that we know is true. The height of the water to begin with is bigger than the height of the water to end with, right? Because we saw right here that the water level fell. So what I'm saying is, if I have a bigger number like 5 divided by a smaller number like 4, is that number going to be bigger or smaller than 1?
Bigger.
Bigger. 5 divided by 4 is like 1.25, right? So it's a number that's bigger than 1. So what I'm saying is, if I get this ratio and it ends up being bigger than 1, then I can conclude that the water level fell, because what I'm saying is the water level before is bigger than the water level after.
Oh,
Right?
That makes
Right?
yeah.
And I screwed up that in my explanation because I was thinking something. I don't know what I was thinking. But here's the conclusion I can make. I'll say ratio. If equal to 1, then stayed same. Stay same. If greater than 1, then fell. If less than 1, then rose. That makes sense. That makes perfect sense to me. Does that make sense to you? Are you sure?
Yeah,
I don't want this to be the part where I lose the 8th grader.
Ratio.
Wait, if one is
If this ratio is equal to 1, then the heights are the same.
yeah.
Then this height is equal to that height.
Right.
If this number is bigger than 1, then the water level fell, because it's saying that the water before is a bigger number than the water level after,
Oh yeah. Okay.
right? So if this ratio ends up being a number bigger than 1, then the water level fell. And if this number being a number smaller than 1, that's saying that the water level after was actually bigger than the water level before, and so I can say that the water level rose. I know it might be a little confusing because you think that bigger than 1 means it rose and
Yeah.
smaller than 1 means it fell, and that's what I initially kind of got tricked into thinking. But when I really think about it, no, this is actually true. If it's bigger than 1, then it falls.
Oh.
Does that make sense to you?
Yeah.
Okay, so check this out. Check this out. We're at the end. We're done.
It's the light at the end of the tunnel.
The density of water, or the density of the penny, is bigger than the density of water, right? So this number is bigger than 1. The number right here, I'm going to put parentheses right here. This density of P divided by density of water is going to be some number bigger than 1. Like, for example, 1.37 or so. I don't know. Whatever it is. Are we cool?
Okay.
If I multiply that by VP, whereas over here, I don't multiply VP by anything.
Okay.
Which one's going to be bigger, the one on top or the one on bottom?
Top.
The one on top. Which means the ratio is bigger than 1. Because the density of the penny is bigger than the density of water, so this thing on top is bigger than 1. So therefore, the water level fell.
Dramatic.
This is just what we do.
Let me take a picture.
I know.
Yeah.
What's QE? What?
Stands for Korset Erat Demonstrat, and it's the
What?
it's the nerdy way in Latin to say, and thus it has been proven. It's basically, when I used to do this kind of stuff in college, I would go QE dizzle.
Drizzle. No.
It's basically just doing like this, like a boss,
And I'm awesome.
Okay.
and then you walk out. That's what it's. That's what it's like. What the Greek mathematicians used to do when they wanted to be like a boss, and then just like
When they
drop,
wanted to be pimp.
drop the mic,
You guys
drop the mic, and be all lit.
I mean that wasn't wrong, so I can't.
Good one, Mr. Alde.
All right.
Stop it.
Stop!
It
No.
died like 2 weeks ago.
That died.
Yeah. No.
Let it stay dead.
I thought that was
Internet
dumb.
trends never
Okay.
die.
What do you think?
I have a
QE
headache,
dizzle
but that was
booyah.
awesome. That was
Right.
pretty cool.
Let's do
Yeah.
another one.
Epic.
No. Time's over.
Yeah. No. Time's up. I
Well,
think.
actually,
No, it's not.
Actually, no. We
30
we have some time.
have some time. I can start teaching. Well, you guys want to play Force Table?
Yeah, I like.
What's
I
that?
want to play
Oh,
Force
wait,
First
Table.
of all, what is that? Second of all, when does this end?
Well, here. Let me stop this archive.
Why are you pointing at me?
What is
So,
what
I
is
have a
that?
question. So
What do I always say?
basically,
Shoots
it's
bra
just
alcohol.
that
Okay, wait.
More water is displaced when it's in the boat than when it's not in the boat.
Thank you.
Thank you.
Yeah.
Okay, that
Basically,
makes the whole.
It's that.
Oh, that makes the
But
whole.
this
The
proves it
density of
mathematically.
penny.
She summarized all that.
No, no.
We get it. We
Yeah,
get it.
obviously.
But that makes it easier to grasp the concept of if the ratio is equal to 1, then the water stays the same, or if the ratio is
Mhm.
greater
What's
than
that
1,
mean?
then the
What's that?
water fell because it means
And what's
that
tacit? No one answered.
No, if the ratio,
3.
yeah, if the
Ends at
ratio
3.
is
Ends
if
at
the
3.
ratio is a bigger number than
I
1,
believe
then the water falls. Yeah,
no one's
because there's more there's
because that means
less water.
that means you took a bigger number divided by a smaller number.
I'm trying to use Miss Soranini's explanation because it helps put the pieces together.
Look, waving my arms. All right, go.
Look what you've done.
Thank you. That was what I was trying to say. This is what
What was say it because I want to
I
make
just
this.
repeated what she said.
Well, no, I want to make this video so it's explainable to everybody. It's understandable to everybody. This makes sense to me, but I mean, what were you gonna say?
More water is dispersed when the pennies are in the boat than when it's not in the boat.
Yes,
That's,
That is
Yeah.
correct.
So like
it's not that
Displaced.
displaced. Displaced means moved.
Yeah. We say disperse again.
Oh, and because the lake is so
No,
small.
dispersed stands for more gas.
because
So.
then if the water's
Sounds
And so
similar.
because the
Let
lake
me
was
live.
so small,
At
the
least I
water
didn't
moved
call
up. Yeah,
symbols
cool.
syllables like 5 times today, like someone in this room. So.
It makes a difference. Anyway,
okay, good.
all right.
I was like,
Questions are gonna stop the video.
Stop.
Yeah, yeah.
Shoots, bro. I'll pout.
You still